Hello?
Hi.
Hello, Mr. and Miss Ryan, are you alright?
Hello.
Okay, so we have this array numbers.
We have a
Can you find the index, the numbers, that the left side, the sum of the left side equals the sum of the right side? The earliest, the smallest index. So let's say if I
2 and 0.
2 and 0. So what do you mean? So if I pick this number,
Yeah.
the sum of the numbers before these four is 5, right? Yeah? The sum after on the right hand side is 9. Okay, so this is not the index we are looking for. So any index that the sum of the numbers on the left equals the sum of the numbers on the right. So which is the index, the smallest index?
0.
Wait, yeah. So what's the sum on the left?
9.
What's the on the right?
9.
Yeah. So we're looking for 0, 1, 2, 3. So you need to tell me it's 3. Easy? Get it?
Yeah.
So this is we given an array. We need to find the smallest index, the earliest index that the numbers on the left sum will be equals to the sum for the numbers on the right. Okay, so look, there's one thing to notice here. This number is excluding the sum. Yeah. So if you the index here, we are not summing, we are not adding this. We're excluding this number on the left and on the right. It doesn't count this number, right? Okay. Okay, so this approach, what's the approach you think in your first thing in your mind? What's the approach?
I don't know.
You don't know. What's the approach? How many possibilities do we have? Why do you say you don't know? Come on, we are looking for the index. So how many indexes are there possible? N. Yeah, we're done. So that could be a approach. True, false, right? Yeah. So we can try each possible number, right? Yeah, we can try each possible number. Okay, let's do this. And then you need to think in mind, what's the term complexity, okay? Define, let's say, index, find index, okay? Numbers. Okay, then n equals length numbers. Okay, then for I in range n, right? So what's the sum? Look, this is the number, yeah? This is the number. 250, what's the number again? 270255, something like that. So we are going through the index for each one. And then if I say this is the index I here. Yeah. So what's the sum of that bit? This bit. Sum. If this is
I minus 1.
numbers, so up to
I minus 1.
up, yeah, but we're up to I, right? Yeah, I not including it, right? And what's this bit? What's this bit? Sum.
I plus 1.
Yeah, I plus 1. I plus 1. Okay. Yeah. So we can just say if sum number up to I equal sum numbers I plus 1, then we return I, right? Yeah, because we're going from left to the right, so the earliest we found is the smallest index. Otherwise, we return minus 1 if we can't find any. Okay. What's the term complexity?
N.
You sure, Owen?
N square.
Oh, n squared. Why is that? Can you tell me why is O n squared? Sorry?
Slow.
Sorry?
Because the for loop and the number string.
Yeah, sum. Yeah. When you sum it, you need to go through this. Yeah. So look, I try this index I, then I need to go through to sum the numbers and then to sum the numbers. Okay. So this is O n squared. Okay. So can we do better? Can we do better? Obviously, yeah. Otherwise, there's no point. Yeah. This is the proof of thing. Everybody can come up with it, right? Yeah. So do you still remember this keyword? Accumulate. Accumulate. Let's say. Okay. Let's say 250522. Yeah. Or maybe 221. Accumulate. What's accumulate? Accumulate. We talk about this accumulate. Is they look 2 plus 2 4 2 plus 2 plus 1 is
5.
yeah. So it means that the sum of the first I numbers. So what's this? What's next?
5,
And then
10, 12, 14.
we're done. Okay. Okay. So now we have these. So if let's say, what's the sum of all the numbers here? Or what's the sum of all the numbers in an array?
It is
What's all the number?
26, 36.
Come on, we just have to look at the
46.
14. Yeah, this is the number of everything here. Yeah? Or we can just say sum. Right? Sum all the numbers. This is total. Yeah, total. And this equals what? This equals to this accumulate numbers, and then minus 1. Right, the last number is the sum of everything. Right. Okay, so if we have these, we can go do this in ON time, right? So why this is useful? This is the called prefix sum, accumulate, prefix sum, yeah, prefix. Yeah. So look, if we are going from here, right? We know it's 5. Up to this point is 5. So we know this total is 14, right? So look here. I know the total number is 14, and I know the sum of the first 3 numbers is what? Is 5. So what's the sum of the numbers up to the end? What's this bit? This is 5. What's the sum of this bit? What's the sum of this bit? Everything here is 14. Here is 5. What's this bit? What's the sum of this bit?
41.
Sorry? 41. Sorry?
9.
9, yes. 14 minus 5 is 9, yeah? Okay, so this is 9. So it means that this number here is 9. Alright? Alright? So
I thought you meant 5 plus 10 plus 12.
yeah, no, not this one. I'm saying this.
That's
Okay,
why I
okay.
thought 41.
Okay, so now look, if we have this number, we can, so basically we have total. This we have to calculate total minus the prefix sum is on the right, yeah? This is the right bit. But we have to get rid of these bit first. So the prefix sum minus this number, if it's equals to this sum, then we find it. Am I right? So look, so put it this way. So here, we are here. So we are here, yeah? We are here. The left bit is 5, right? The first 4 numbers, the sum of the first 4 numbers is 5. Minus the fourth number is 0. So the first 3 number is 5 minus 0, right? The sum of the numbers next to on the right hand side of 0 is what? Is 14. This is the total number minus 5, right? Is it minus 5? 14 minus 5. Okay, so this is 9. Okay, so that's not equal. So that's not equal. So this is not the first example I give at the beginning, right?
Yeah, you didn't.
I think that's a problem. Okay, let me rewrite the example.
You did 2, 3, 4, 0, 5, 2, 2. That's right.
2, 3, 2, 2,
2, 3, 4.
2, 3, 4. Okay. So yeah, that's not the same. Okay, but the principle is the same. Okay, the 2, 3, 4, 0, 5, 2, 2. Okay, let's do it. Okay. 2, 3, 4, 0, 5, 2, 2. Okay, and the accumulate will be 2, 5, 9, 9, 14, 16, 18, right? This is accumulate. Right? Accumulate up to this one. Now we are at this, which we try each possible index. And if we say we are here, right? We're here. So the prefix sum of the sum of the first 4 numbers is 9, yeah? Yeah? And 9 minus this number 0. So that will be the sum of the first 3 numbers, which is 9 minus 0, which is 9. This is the sum of the first 3 numbers. Yeah. Okay? The sum of what? The sum of these number. The numbers on the right, yeah, which is 18, right? 18 minus 9, right? Oh no. It's 18. So this the sum of the numbers on the right is 18 minus 9, right? Here. So which is 9. Right? So look, we have a match. 9 equals 9. So let's say this is the index. Make sense? Yeah? Yeah? Got it? So look, we just look it up. So the previous example, why is this low O(n) squared? Because we have to calculate the sum here, yeah? Yeah? But now we don't calculate it. Instead, what do we do?
We accumulate it.
This one, we just look it up, right? But the number on the right, it's just the mass subtraction. I know the total numbers, the sum of the total numbers. And I know this bit. Right? Are you right? I know this bit. So the subtraction will be the sum on the right. Am I right? Okay, so let's do this. Okay, so let's say, so accumulate, so let's say total, we can say total, t equals sum of all the numbers, yeah. First of all, we get the numbers, yeah. Right? And then the prefix, let's say p equals, let's put a 0 at the beginning and I'll tell you why, 0 plus, I put a 0 at the beginning, and then list, accumulate, numbers, numbers. So p, we put the 0. So so what's the last value of this p? What's the last value of this p? Remember, accumulate. What's the last value of the
total sum of all.
Yeah, so instead of, look, we're going through this once, we're going through this twice. So instead of that, we can just do it once, then we can say t equals p minus 1, okay? Yeah? That's one improvement. So instead of iterating the array twice, we're iterating once. Yeah? Because when we do this accumulate, the last value is the sum, and we get the sum for free. Right? We don't need to go through it again, right? Now look, and then I can go through this index for I in range length numbers. Yeah, because we're going through the numbers, and then we just have to do what? We just have to do if the p I equal the total minus pi plus 1, okay? What does it mean? And then we return I. Otherwise return minus 1. Okay, so what does it mean? Let's say 2, 3, 4, 0, 5, 2, 2. Again, this example, yeah? So the accumulate function will be 2, 5, 9, 9, 15, 16, 18. Okay, look, I put a 0 at the beginning, yeah? I put a 0 at the beginning for the p. And I go through this. I will be here. If pi equals t minus pi plus 1, right? Okay, so now I'm at here. ti minus 1 is not equal. Then I move to the next. If pi, which is 2, t is what? It's 18, yeah? T is 18, which is 18. This is 18. Okay? So look, if I is at this point, yeah? 0, 1, 2, 3. And I plus 1 is also 9. Because 18 minus 9 equals 9, right? Look, pi is 9. Pi plus 1 is 9, also 9. T is 18. So look, then we found the match here. Now we return I, okay? The reason we add a 0 at the beginning is that, why is that? Because that it could be possible that it could be possible that if we start from the first number and the sum before the first number is 0, because there's no number before the first number, right?
So it's like 2, 0, 0, 0, 0, 0.
So because the index, when I is the first 0, it means the first number, yeah? It's first number. So if it's the first number, then there's no numbers before the first number. So the sum is 0. So we have to capture this, right? Okay, so what's the time complexity in this case? Look.
O(n).
O(n). Why is it O(n)? Why is it different than the previous one?
It's because that you
So this is on. Then we put it up in a p. This is array. And then look, pi, prefix sum. Instead of calculating the sum, we just look it up. That's O1 constant, right? Do you see the difference? The previously, what's the previous one? This one is what? Previous one is what? Sum the numbers up to I, right? Right? This is O1, right? But instead, I put it here. I do this accumulating. So I only need to do this once. And do I need to change it? I know. No, right? I just have to look it up, right? Okay. This is one way, okay? Another way, quite simple. Is it quite simple? You'll be very, very simple, yeah? Quite similar idea. But instead of doing this lookup, we can just do this. It's quite similar idea, okay? Let's say 2, 3, 4, 0, 5, 2, 2. What's the total sum? What's the total?
Sum is 18.
Total sum is 18, yeah? Sum numbers. When we do this sum numbers, what's the time complexity? We're calculating all the sum of all numbers. What's the O-N? Yeah, we know. Because you have to iterate over all the numbers in order to find the sum, yeah? Yeah, that's obvious there. If you don't visit the number, you don't know the sum, right? Yeah, that's all I know, yeah. So that's total number is 18, okay? Okay, so that I have the left bit, I have the right bit. Yeah, right is the t equals 18. Okay, so what's the first number? What's the first number? No, okay. What's the first number?
First number is 2.
2. Okay. So 2. So
Right.
left plus equals 2. Okay, plus 2. So what happened to the right?
It's subtract 2.
Subtract 2, yeah? Yeah? Subtract 2, so it's 16.
Stain.
Okay, I put a 3 on the left. Plus 3 equals 5. So I need to remove 3 from the right. Yeah? So basically, you can think of these as the left and right. Left and right. You move it. So what you increase you put this number, you increase the one number on the left side, so that needs to be taken out from the right hand side. Can you imagine? Yeah? Make sense?
Yeah.
So look, plus 3, plus 4, and then plus 4, which is what? 9, yeah? And I need to get what?
Subtract 9.
13, and now 13. And then now I need to minus 4, which is 9. Okay, and then I found the match. When left equals right, I found it. Make sense? Okay, can you explain this method to me again? Come on. Can you explain this method to me?
You have left hand and right hand. You just move.
So when I include this number 4 on the left,
The right gives it to the left.
Exactly, perfect. That's the perfect explanation. The right gives the number to the left. So the number needs to be deducted from the sum of the right and needs to be added to the left. Right? So when I have a match, that's it. Okay? So this is quite similar, yeah? It's quite similar to the second approach, okay? Okay, so look. So right, let's say right at the beginning is the sum of all the numbers, yeah? This is O(n) 10, right? And then left equals 0, at the beginning is 0, right? Left equals 0, okay? So now, for the index and the number, yeah? For IC enumerate, what's enumerate? Come on.
It shows the index and the value.
Yeah, we're done. Index and the value. Okay, now, the right needs to minus equal C, right? We take C out of the sum of the right, right? Right? And then if left equals right, then we return I, yeah? This is the index. Then otherwise left plus equal C, right? Make sense? Yeah? And then return minus 1 there. Yeah, you get it? Right, look. First of all, I take the C, the number from the right hand side. And then look, there's a pitfall here. So we need to check before we add it. So why is that? Why we need to check it before?
So we.
Okay, 2. Why is that? Because what? Because there's if a single number like 2. Single number. If this is only single number, what's the sum? Sum is 2. Right? Right minus the first number is 0. Right? And left is 0. So if it's a single number, the earliest index is 0. Right? Right? Any single number, what happened?
You have to do that.
Look, any single number, look, this is I. The sum before the first number is 0. Here, this is 0. On the right is 0. So any single number, the earliest index is 0. So right, look. So right minus equal the first number is 0. Left equals 0. If you do this first, what happened? Left plus equals C. Then left will never be the same as right. Make sense?
Mm-hmm.
Yeah? If there's a one single number, what happened? If right minus equals C, right is 0. And then you give it to the left. Left is not 0. Left is 2. So left is not equals to right. Yeah, you see the problem. So that's why I need to make sure left equals right. You get it?
Yeah.
Yeah? Look, only one single number. The sum is 2. Right minus C. What's the value of right?
Right is nothing.
0. Yeah? What's the value of left at this point?
2.
No. I haven't go here. What's the value of the left?
Nothing.
Nothing. Okay, so we should return, right? Because look, if I is the index, the sum before the first number is 0. The sum after the first number is 0. Okay? Yeah? If we add it to C, then C, the left is 2. Right? So they will never meet, then we return minus 1. You get it? Yeah?
Mm-hmm.
What's the time complexity? Come on, what's the time complexity? ON, right? This is ON. This is ON. We're going to I and C, yeah? I is the index, C is the value, okay? Right, we take this value out of the right. We check with the left. If it's the same, then we find it. Right?
Mm-hmm.
Yeah? Why this is okay? Because we are not counting this number, the index, the value at the index I. Make sense?
Mm-hmm.
So, yeah? And if this is not the case, we will move it to the right. When we move it to the right, look, we move it to the right. I plus 1, I plus 2. When this is not the case, this is I minus 1, we move it to the right and then we need to add this number. We need to add this number. Yeah? We need to include it in the left and then left still on the right. Yeah? So we want to move it. When we move it, we need to, first of all, we need to erase this from the right. Yeah? But now we need to check the left and right bit. Right? Look, we are not counting this number. We need to take it out. And then we need to check the sum of left and right if it's equal or not. If it's equal, great, we return. Otherwise, I need to include this number to the left. Right? Mm-hmm. Alright? Got it? Okay? Yeah? That's it for today. Bye-bye. Bye-bye. Come on.
Bye.
Do some dancing, please. Do some dancing.
Bye, babies. Bye.
Bye-bye.
Babies.